We're given a lot of information in this question, but it's mostly on the diagram. We've got that y lies on AC. That is useful to know, but it looks like it does, but we should never assume it technically. ABC and AXY are right angled and the right angles are shown, and AX equals BX, which is also indicated by these little lines. The line segment AX bisects BAC, which actually means that the two angles at the top, these two, are the same. And then angle X, AXY is 7 times the size of angle XBC. Now, you're going to need to work algebraically for this question and call an angle X. I actually went and called this one X, and I'll go through that way in a minute. It's a little bit more complicated because I end up with fractions. The best way to do it, arguably, is to say that this angle here is X. Because what that means is that AXY becomes 7x, and we avoid fractions. By starting with the one that is 1/7 of another angle, we times by 7 instead of dividing by 7, which I'm going to do in my second method. But the process is then going to be very similar. So I've used that bit of information. It must be then that XAY is 90 minus 7x, because angles in a triangle add up to 180. And then this other one, AX is going to be 90 minus 7x as well, since remember, AX is a bisector. That means that this angle is 90 minus 7x because of the isosceles triangle, which I'm just going to highlight in red. And I've got all the information I need because I can look at the whole triangle now and say 90 minus 7x plus 90 plus 2 lots of 90 minus 7x, which is actually 180 minus 14x. That must equal 180. So I can cancel out the 180s to start with and try and solve for x. Combine some like terms. I've got 90 plus 90, that's 180. And I've got minus 7x minus 14x, that's minus 21x, plus x, that's going to be minus 20x. Therefore, 20x is equal to 180. So 2x is 18 and x is 9. We're not quite done, but we're nearly there. We now just need to work out this angle. So angle ABC is actually going to be 90 minus 6x. So 90 minus 54, giving me the final answer of 36 degrees. Let me just show you an alternative. This is how I did it originally. I just went straight in and said, you know what, I'm going to call this x and this x. And that means that this is 90 minus x. The bit that makes it a little bit awkward is that now this is 1/7 of that. See, when I started with it and called it x, I times by 7, but now I have to divide by 7. And that will also be x here. But we can construct an equation still. It's going to work out. The equation to some extent is a little bit simpler, except to divide by 7. I'm going to get 3x by adding these and these, plus 90 minus x over 7, plus 90, this angle here, and that must equal 180, which means that the whole thing without the 90 must equal 90. Okay, the only difference now is I need to times through by 7. Times both sides by 7, which is actually equivalent. I could put 21 here. Sorry, not 21, 7 here. It's going to give me 21 in a minute. And then 7 here. And I times them, so I get 21x, and then when I times this one, the 7's just cancel. You can, in fact, just times each term separately by 7. That means 20x is going to equal 540. 2x is 54, so x is going to be 27. Put that back in, I'm going to get 27 here. And over here, I'm going to get 90 minus 27, which is 63, divided by 7, which gives me 9. Overall, that angle is going to be 9 plus 27, again, give me 36. So just an alternative if you prefer, or just to see different methods. There's lots of different angles you could call x. I think those two are the most natural. Either like this is a good way because it avoids fractions. Seems quite a natural way as well, the way I did it. I probably wouldn't think to call that one x or anything, but there's, as long as you can construct the equation and solve it, you will get to this answer of 36.